So just to look now at the fractional error. Okay, so the fractional error formula, he didn't actually mention the fractional error formula in this video, but he actually already done it. He actually already did it. The fractional error formula is basically the true value or the accepted value minus the measured value and then divided by the true value. But again, you take the absolute value of the difference between the two of them. Okay, so he has actually already calculated, he just didn't really labor the point. So you can see there that the true value, which was 6.72, it doesn't really make a difference about the order either, because you're getting the absolute value of it, it doesn't matter if the big one comes first or second, because it'll always work out to be positive. So he's actually put the measured one first, but I'll do it the other way around. It doesn't make any difference. The true value was 6.72 feet minus 6.8 feet. Again, taking the absolute value of those two numbers and then dividing it by 6.72 feet, which was, again, the true value. Now, when you work that out, that works out to be 1/84. So this is expressed as a fraction. Notice again, there's no units because the feet above cancel with the feet below. And again, this is known as the fractional error. Okay. So the last thing that we look at here is the percentage error, and he's already done this one. So I'll just make one or two comments on it. Again, depending on where you look, you see this formula written in a variety of different ways. Percentage error, I prefer to write it down as percentage error is the true value minus the measured minus the measured value. Again, absolute values of those two divided by the true value and times 100%. So basically what you can do is you take this is essentially the fraction. This part here was the fractional form, which is 1/84, and you take 1/84 and basically express it as a decimal, which is, as he said in the video, 0.0119 times 100%, scaling it up by that factor of 100, and that gives us 1.19%. Now again, the only comment that I would make on this is how you would normally report it in a lab. So if your measured value, or sorry, your true value or your average value, because the true value is usually based on your average value. So if that was 6.72 feet, the unit would go here plus or minus 1.19%. Okay, and you would usually state that in the results section of a laboratory experiment or something like that. Okay, you'd usually come up with the results and also in the conclusion. So you'd be drawing a conclusion. We found our value to be 6.72 feet plus or minus, just to give us an indication of what the spread was on your results of 1.19%. Okay, so I hope that makes sense.